Solubility is defined as the amount of a given substance that can be dissolved in a certain amount of solvent. So far we've talked about things as either being soluble, meaning they would completely dissolve, or insoluble, meaning they won't dissolve at all. However, some things can be described as slightly soluble, and even substances that are extremely soluble, like salt, there is a maximum amount that you can dissolve in a given amount of water. So solubility tells us exactly how much is the maximum amount of any given substance that can be dissolved. And the solubility of a substance must be defined at a specific temperature and for a specific volume of water. If we start with dissolving solids and liquids, if I have a cup of tea or coffee and I add sugar to it, I can dissolve a certain amount of sugar in that water. However, if I keep adding sugar, I can't get all of it to dissolve because there is that maximum amount that I can get to dissolve. However, what that maximum amount is does depend on the temperature. For solids, as the temperature of a substance increases, the solubility increases. This is why you can get more sugar to dissolve in a cup of hot coffee than you can to dissolve in a cup of iced coffee. When we have gases dissolving in liquids, however, these are affected by both the temperature and the pressure. If we start with the pressure component, think about a bottle of soda. Sodas contain dissolved carbon dioxide, which is a gas. And when I open the bottle of soda, the bottle fizzes. That's the carbon dioxide coming out of the solution. Once you can see the different parts, it's no longer dissolved because a solution, by definition, is a homogeneous mixture. So when I see the bubbles forming, that means the carbon dioxide is undissolving from the soda solution. When I open the soda bottle, those gas particles start to undissolve. So let's think about the pressure inside of a soda bottle versus the atmospheric pressure that we're now opening the soda up to. Sodas are bottled under very high pressure. So when I open the soda bottle, the pressure is decreasing. So when the pressure on the soda decreases, the gas undissolves. This means the higher the pressure on the soda, the more soluble the gas is. It's bottled under high pressure so that that carbon dioxide can stay dissolved. Temperature will also affect the solubility of gases. If I have a cup of cold soda and a cup of warm soda sitting out on the table, which one's going to go flat quickest? Well, the going flat means all of the carbon dioxide has undissolved. The cold soda stays fizzy longer because it's able to retain carbon dioxide better. For gases dissolving in liquids, the gases will dissolve better at lower temperatures than they will at higher temperatures. Now, the solubility tells us how much of a solute it takes to make a saturated solution. A saturated solution is one that is containing the maximum amount of solute that it can. If I were to pour more solute into a saturated solution, no more is going to dissolve. All of that extra is just going to settle down to the bottom. If I have an unsaturated solution, that means it's not full yet. If it can hold 100 grams of solute and I've only put 5 in there, it's unsaturated. If I add more solute, that extra solute that I add is going to dissolve, at least until it becomes saturated. The weird one is the supersaturated solution. A supersaturated solution is one that actually holds more solute, meaning more is actually dissolved into that solute, into this solvent, than can be dissolved under those conditions, temperature and pressure. but all that stuff is actually dissolved, meaning you can't see the extra particles. The only way you can tell that it's supersaturated is when you disturb the solution by like adding another crystal in it, extra stuff starts to come out. So if we look at this example here, it shows I have a solution of some type of chemical here. It looks clear. You can't tell that there's anything dissolved in that water. There is. But by looking at it, we can't tell that there's anything dissolved in the water, and we certainly can't tell whether it's saturated, unsaturated, or supersaturated. However, when that little crystal that's being held by the tweezers is dropped into the solution, all this extra stuff starts to precipitate out of the solution. That's because the solution over here is supersaturated. It contains more dissolved in that solution than it can hold. It's a very unstable solution, and if something is done to disturb the solution, all of that extra stuff is going to precipitate out. So here I have two beakers. This one looks like a beaker of water. There may be stuff dissolved in it, there may not. This one is a beaker of water that's got some solid stuff sitting at the bottom. Now what can we determine about the saturation of these two beakers? Well, the first one, it could be unsaturated. It could be saturated, having exactly the right amount to dissolve that it can hold. Or it could be supersaturated. We have no way of knowing what it is by just looking at it. The only way to find out would be to put in a little extra. If that little extra dissolves, then the solution was unsaturated. If the little extra that's put in just falls to the bottom, then it would be a saturated solution. If that little bit extra causes more crystals to precipitate out of the solution, then the original solution was supersaturated. The extra stuff that precipitates out is all of that extra that it can't hold, and I'm left with solid particles, and the remaining stuff that's dissolved does make up a saturated solution. This beaker, however, assuming that the solid wasn't just added to it and it's actually been sitting there long enough that everything that could dissolve will dissolve, this solution has to be a saturated solution. All of that extra stuff that can't dissolve is sitting at the bottom. If it were unsaturated, the stuff that was sitting at the bottom would be dissolving. If it was supersaturated, the fact that there are other crystals here down at the bottom would cause all of that extra stuff to precipitate out and form crystals, just like we saw in the last picture. So solubility depends on temperature and pressure when we're dealing with a gas, but only temperature for a solid. And our solutions can be either saturated, unsaturated, or supersaturated.